Lesson 4.8, hypothesis testing. Our objective for this lesson is to be able to formulate null and alternative hypotheses and to determine whether a sample provides evidence for rejecting a null hypothesis. So let's start by defining hypothesis testing. Hypothesis testing is a way to test the results of a survey or experiment to see if the results are meaningful. So we're going to use what we learned in the last lesson about statistical significance to test whether we have evidence to support some hypothesis. And the evidence is going to support that hypothesis if the results are statistically significant. And this hypothesis testing happens in a bit of a roundabout way. And here's what I mean by that. We're going to start with a null hypothesis. So the null hypothesis is the starting assumption for a hypothesis test. It is essentially that there's nothing to see here. The null hypothesis is generally the status quo. We're going to say that the population parameter is equal to some value, usually the mean of whatever it is we're looking into. So for example, if our claim is that our dog food, that dogs that eat our dog food live longer than dogs who don't eat our dog food, then our null hypothesis is basically going to be the opposite of that. It's going to be that the average age of dogs who eat our dog food is equal to the average age of all dogs. So that's our starting assumption that nothing is really happening. Then we have an alternative hypothesis. An alternative hypothesis is a claim that the population parameter has a value different from that claimed by the null hypothesis. So in our example of the dog food, if our null hypothesis is that the average age of dogs who eat our dog food is equal to the average age of all dogs, then our alternative hypothesis is going to be that the average age of dogs who eat our dog food is greater than the average age of all dogs. And we're hoping to be able to support our alternative hypothesis with the results of our experiment. All right, so there are two possible outcomes of a hypothesis test. We are either going to reject the null hypothesis because we have evidence in support of the alternative hypothesis. So remember, with hypothesis testing now, rejection is good. We want to reject the null hypothesis because then that means that we have evidence to support our alternative hypothesis, which is what we're trying to prove. It's our original claim, essentially. The other possible outcome is that we do not reject the null hypothesis because we lack sufficient evidence to support the alternative hypothesis. Now notice here that we don't ever accept the null hypothesis. We don't prove the null hypothesis. We either reject it or we don't reject it. If the results of our survey or experiment are significant, then we're going to be able to reject the null hypothesis and support our claim and essentially prove our alternative hypothesis, which is our original claim. Or we're going to not reject the null hypothesis, and all we can say there is we don't have enough evidence to support our claim. Our example says that each baseball in a random sample of 40 new balls is dropped onto a concrete surface and the bounce height is recorded. The heights have a mean of 92.67 inches. A manager claims that the mean bounce height for all baseballs is 90.10 inches, and the likelihood of observing a sample mean of 92.67 inches is 0.035. State the null and alternative hypotheses and discuss whether the sample provides evidence for rejecting or not rejecting the null hypothesis. All right, So let's start with our null hypothesis. We generally write the null hypothesis as H naught or H sub 0. This means the null hypothesis, and we're going to say that our null hypothesis is that our, in this case, the bounce height of these new balls is equal to 90.10. That's the mean height for all baseballs. And so basically what we're saying is that there's nothing special about these new balls. That the null hypothesis is that the bounce height is equal to the mean of all baseballs. So our alternative hypothesis, which we'll write as HA, sometimes written as H1, our alternative hypothesis is going to be that the bounce height is greater than 90.10. And we're told that the probability, if this is true, that the bounce height is 90.10, then the probability of getting the results that we observed, that of a bounce height of 92.67 inches, the probability of that happening is equal to 0.035. And so we want to know whether we're going to reject the null hypothesis or not reject it. So we have a couple of different answers here. If our predetermined level that we wanted to get to was 0.05, so if we want to accept or reject the null, or reject or not reject the null hypothesis at the 0.05 level, then here we're going to we are going to reject the null hypothesis. So at the 0.05 level, we're going to reject the null hypothesis. And again, this is a good thing. That means that we've proven that these balls bounce higher than the normal ball. So we're establishing our alternative hypothesis by rejecting our null hypothesis. Now, at the 0.01 level, which is a level is a bigger hurdle, a stricter standard to reach, because now we're saying that this has got to be significant in such a way that the chance of this happening randomly would be less than 1%, or the probability of this happening by chance would be less than 1%, and we don't have that. So so we're going to say do not reject if we were shooting for a 0.01 level, and this level should have been determined before we ever started the experiment. So our alternative hypothesis is that the bounce height is equal to 90.1, or the null hypothesis is that the alternative hypothesis is that the bounce height is greater than 90.1. And with the results that we observed, we're going to reject the null hypothesis and accept the alternative hypothesis if we were shooting for a 0.05 level. But at the 0.01 level, we're not going to be able to reject the null hypothesis. And all we can say there is that we just don't have enough evidence to support our claim.